Now, to talk about who is leading in these systems, as you said, for vehicles, for hybrid vehicles, Toyota, Honda, General Motors, these guys have worked a lot on hybrid vehicles. They have a lot of models and they have a lot of research that's already done. Tesla is one of the major OEMs that deal with electric vehicles, and they seem to be doing pretty well in United States and Europe and other places. Uh, so these are the vehicle. That's like the overall system. But you need the hybrid systems. You need to make the e-motors. So there are a lot of like Toyota, Honda. Generally, they make all these systems by themselves. But there are also there are also supplier companies that are working on this now. Also ZF, Borg Warner, Bosch, Schaeffler. So these are a couple of the companies that work on developing these systems. So recently, BMW gave ZF an order for like a hybrid powertrain for their coming SUV, I think. Then there are battery suppliers. So CATL, that's a big Chinese company. I think it's the biggest battery manufacturer in the world. Then there's Panasonic. Tesla batteries are made by Panasonic. Then there's BYD, LG Chem, Volkswagen, I think, is working with LG Chem, Samsung. So there are these companies that are working on developing the batteries. Now, all these systems are a little complex, so you need more controls for that. So for these controls, there are different companies like Delphi, Bosch, Denso. They are working on these systems. Then, as I said, the whole system is complex since you have now an engine as well as an electric motor for hybrid vehicles. So there are some companies that do consulting or do basically work with the OEM to help them develop these vehicles. So FEV, AVL, these are a couple of the big companies that do that. In terms of typical job roles, as I said, the hybrid electric vehicle industry is a pretty multidisciplinary domain. And you need to have a lot of system knowledge to work on this. So there are different roles. So one of the major things will be mechanical, since you're working in an automotive industry. So mechanical will deal with the overall powertrain system design, component design. You do with work with on simulation of these systems, on testing them, testing the components, testing the entire vehicle, putting them in a vehicle, then doing calibration of the vehicle, testing. So that all these domains, these roles would be in on the mechanical side of things. Then since it's a hybrid, there's an electric part of it. So you need electrical engineers to develop the electric motors, the entire electric system, the battery system, like high voltage system, power electronics. So electrical and electronics deal with that, developing the controllers for the batteries, for the motors, and etc. Then since there's a battery, you also need guys who work on battery. So there can be from different fields. For chemical engineers that deals with chemistry and all that stuff, with advanced materials, there's a lot of work in the battery department. Then again, since it's a complex system, you need software to control them. So even software engineers are working on this, developing the software and how everything works on like a component level and a system level. And these vehicles are generally high voltage vehicles. So that means there can be safety concerns. If you touch a high voltage connection line, that can be dangerous and lethal. So there are different standards that are made to protect against people who are working with these vehicles, and in terms of a crash and how everything should work together. So there are people who will be working on the standards. So they can come from different fields, be it mechanical, electrical, or any other field. So these are generally the job roles that you'll find. Next would be hybrid electric vehicles. So we'll go into detail of what an hybrid electric vehicle is. It says my internet connection is unstable. So if you look, there's a picture on the right, which is basically shows the internals of a plug-in hybrid vehicle. So you can see there will be an internal combustion engine that generally takes in fuel, gives out torque, and then there's a battery pack on the back side. There's an electric motor that's connected to the engine. There is a charger to charge the battery pack. There's a DC-DC converter that basically converts like the high voltage power from your battery to all these small lights and everything, small electronics that are required to run the vehicle. So these are generally the components of a hybrid vehicle. And the hybrid electric vehicle, as the name suggests, it combines energy from petrol and electricity for power and propulsion. And since it's a pretty vague definition, there are a lot of different architectures and level of electrification that can happen in an hybrid electric vehicle. And these are generally the main questions that should be asked, because the architecture and the system voltage, it determines what the vehicle can do and how much efficiency gain you can get from that system. So again, just the primary energy source is petroleum, be it petrol or diesel or natural gas, and you have an internal combustion engine to convert that petrol, convert the energy stored in the liquid fuel into power, useful power. And then the secondary energy source would be electricity, and you can store the electricity in a battery and use electric motor to convert that into propulsion. So we'll just go into details of what the subsystems are of the hybrid vehicles. So as I said, there's an internal combustion engine, converts fuel into power. And the issues with this is combustion produces those greenhouse gases, carbon dioxide, and also emissions which are harmful for your health. Then second is electric drive unit or electric motor. So that converts electric energy into propulsion, but it also converts your kinetic energy back into electric energy. So there's a two-way energy flow that can happen in an electric motor, which doesn't happen in an internal combustion engine. And this is based on architectures. You can have multiple electric motors. And the good thing of electric motors are they're highly efficient. They can range from 90 to 95% efficiency, even more. And they don't produce any emissions when they're running. So it's all through electromagnetic principles. So there's no combustion or anything that's happening. Then you need a transmission. So transmission is basically anything that will link these power units to the wheels to convert those powers into useful power that you can transfer to the wheels. So that's what a transmission will do. There's a fuel tank that's used for obviously storing the liquid-based fuels. Then there is a battery. So a battery would generally be used to store the electric energy. So electric energy can either come from from your wall socket, or it can come from the engine. But this is a big battery pack that will store the electric energy that will be used by the electric motor. And then you need power electronics, which basically is the link between the battery and the electric motor and all the other electric systems. It is used as a controller for electric motor, and it can be also used for like charging and again converting high voltage to low voltage. So some of the advantages of hybrid electric vehicles. The most basic thing is reduce idle losses. So what that means is when you are at a traffic signal, your engine doesn't stop spinning, so it's still rotating, and that still takes some fuel, and that's just wasted fuel and emissions. So using a hybrid vehicle, you can stop the engine, and then when you want to go forward, the engine will quickly come on, and so you can save on those idle losses. Second point is regenerative braking. So you will generally hear this term, regen braking. So that's one of the basic things too. that putting an electric motor, as I said, electric motor can convert the kinetic energy into electrical energy. So you, instead of using your brake pads to slow the vehicle, you can use regenerative braking. So you can use the electric motor to brake the vehicle, and that will convert some of the kinetic energy of the vehicle back into electricity. So you can charge the battery back. So you can overall reduce the energy consumption of the vehicle. Then second is you can improve, third is you can improve the engine efficiency itself. So one of the issues with an engine is it's only efficient in a very small region, operating region, generally low speeds and high torque. So only at those points engine is efficient when the throttle valve is completely open. So you have low pumping losses and etc. So you can improve the engine efficiency in a hybrid vehicle by load point shifting. So what that means is you can make even if you don't need that much power at the wheels, using electric motor, you can put more load on the engine and you can make the engine operate at a higher efficiency, convert that extra energy into electricity, which can be used later in the drive cycle. Then you can do electric driving. So just use the electric motor to drive the vehicle. That will not produce any emissions, so there will be zero emissions coming out of your pipe. And since electric e-motors are highly efficient, so you use less energy. Then there is sailing. Sailing, what does that mean is when you're going at like 50 kilometers per hour and you let go of your accelerator pedal, the engine is connected to the wheels and it has some engine braking, and that will slow the vehicle. So you're losing some energy in the engine when the engine is doing engine braking. So using hybrid vehicles, you can disconnect the engine and you can save on that energy loss. You can use an electric motor to convert that energy back into electricity. So that's what sailing means. Then there's downsizing. Basically, putting an electric motor lets you put a small engine, and as I said, if the engine is running at a high load point at low speeds, it's more efficient. So by that combination, you can improve the overall system efficiency. Then you can have improved performance. So as electric motors can provide very high power, high torque at low speeds, so you can get better performance out of them at low speeds, and that's an overall advantage from the customer point of view. Then again, if you improve the overall efficiency of the system, you reduce your dependency on fossil fuels. You'll use less petroleum, so there's less emissions and less air pollution and all those issues that come with it. Some of the disadvantages of these systems currently are, they are very expensive. Since you have an engine, but you're also putting in battery and an electric motor, so that increases the cost of the entire vehicle. It increases the complexity since there are extra parts that are added and you need to make them robust, so anything can, like, more parts means more chances of it breaking down. So it increases the complexity. It increases the weight. Currently batteries are basically they don't have as much energy density compared to a normal powertrain. So to have the same amount of energy, you have to put a bigger battery, and bigger battery means it takes more space and it's more expensive and it weighs a lot. Then there is, again, if you have more components, you have less space for passengers, less space for people, and less space for your bags and cargo space and etc. And again, increases the control system complexity. Now we go into a case study for hybrid electric vehicles. So we start with the P0 hybrid. So what P0 hybrid means, it's a parallel zero level hybrid. P stands for parallel, and this is one of the basic architectures to make a vehicle hybrid. And they are also known as microHybrid start-stop system. So I've put up images of some vehicles that use that. So on the top right, it's a Saturn vehicle. So that's by General Motors, GM. This was one of the first vehicles to have a P0 hybrid. Mahindra, Scorpios, and other vehicles, they are making these kind of hybrids a standard. So you will see a microHybrid badge on the back of a Scorpio, that basically means it has this architecture. Then even in Audi, so even in the expensive cars, they have made it a basic feature to have this kind of system in their vehicles. So what this system basically does is it can shut off the engine when it's idling, when you're at a traffic signal or something, when the vehicle is just idling at 700 rpm, 800 rpm. It will shut the engine off so that the engine goes to zero speed. You are not using any fuel to keep the engine from running, and it is very beneficial for like urban environments when you are in a traffic stop and go environment. If you're stuck in traffic, most of the time your engine is just idling and wasting fuel. So it will stop that, and it's better for the environment and the entire, in terms of fuel efficiency gain. So you'll have to spend less money on fuel, and also reduces the greenhouse gas emissions. So that's one of the major feature of a P0 hybrid vehicle. But it can also provide boosting and regenerative braking depending on the battery size and the motor size. So it can provide a boost of power for high acceleration events for a short duration, and it can also do regenerative braking to get some of those energy used back into the battery. So we'll generally go over like a product development cycle. So when we talk about development, it's a pretty complex process. It starts with requirements from the customer or anyone that's coming, and then you convert that requirements into a system design, overall how the system should look, what all components it should have. Then once the system design phase is passed, then you go into component design, like how you are going to design that system. So you have to design the different components. So it goes into that. Then you go into making that part. Once you made that part, you have to test it. So it's like a V, it goes down, and then once you've made it, you have to test that particular part. Now, once you test the particular component, you go into making the entire assembly and the system, and you go into system testing. And once you pass that, like integration testing, and once you pass that, you put it in the vehicle and you do the entire system testing. So this is generally the product development cycle. In this course, we will mainly deal with the system design. So we get some requirements, and how would we convert those requirements into system design? How would we would analyze those systems, do those simulations, and try to find out if we are actually getting any benefit from that system before making the system. So this is beneficial as it saves time and cost. You don't have to make the part before testing it, so that, because if you just make the part before doing any simulations, it might turn out that it doesn't work as intended. So you have wasted a lot of money and time in making those parts. So this is one of the important steps that you need to take before doing that. So in terms of system design, we'll talk about what all systems are there in a P0 hybrid. So generally they'll have a motor generator unit that can be called as a belted starter generator or belted alternator starter. So you'll read different terms, BSG, BAS. What that basically does is your normal engine has an alternator. So what the alternator does is connected to the engine, and it converts some of the energy from the engine back into electric energy to keep your 12-volt battery charged, to run all your air conditioner, your electric circuits of the vehicle. So it replaces that with a bigger motor basically, and that motor can provide motoring as well as generating power. So it can give power to the engine, it can take power from the engine. It's generally a 12 volt to 48 volt system. So in hybrid vehicles, there's a term known as like high voltage systems and high voltage safety. What that means is if your battery system is more than 48 volts, it's termed as a high voltage system, and there are different safety requirements for that. So these are generally basic systems. So they can be either 12 volt or 48 volt. They'll generally be less than that. They won't be more than that, because if you want to go more than that, you can put a bigger motor and you can have a different architecture. So this is just the basic entry level hybrid architecture. so that they can deal with a lower battery level system. And you'll have a normal engine, you'll have a normal transmission, everything is normal. You just add a electric motor, it replace the alternator, put a bigger motor, and you can get a belted starter generator or P0 hybrid system. So in terms of placement, you can see on this bottom graph, there's an internal combustion engine, an electric motor is connected via a belt, and then there's a normal vehicle with a transmission, clutch, and the differential. So these are a couple of images that are taken from the Mahindra's microHybrid system. So as you can see, the highlighted portion, this is a battery, this is a belted starter generator. So it's a bigger motor, and then there's a battery. I think it's a lead acid battery itself that's powering this motor. And on the right side, you can see like the basic architecture. So there's this engine, blue in color with the 4 cylinders. Then you see a BHG, that's the belted starter generator. You have a battery. You have an EMS, that's basically your management electric management system, or basically a controller for the motor. Then it's connected by LIN networks, CAN networks. These are different network protocols for connecting these different components together. And you have a stop-start switch and the other sensors, etc. So generally 2 different modes of operating the motor. One is used for startup and boosting. So what that means is if you need to start the engine, you need to provide torque or power from the BHG back to the engine. So what it does is it takes the power from the battery, goes to the BHG, and that is provided to the engine. So that can be used for engine startup. So when, let's say, you are in a traffic signal and you have put your foot on the brake, so once you let go of the foot from the brake, the engine will start up. So this motor provides that instant torque to start the engine. And it can also be used if you want to pass someone, if you want to overtake someone, you increase the accelerator pedal input, and at that instant this electric motor can provide extra torque and extra power to your system. So that is one way of operating that. And then there is regenerative braking on the right side. So the whole path is reversed. So it's taking energy from the wheels through the engine, putting it into electric motor and then into battery. So what that does is, if you want to brake the vehicle, some of the energy can be taken back to the battery, and you can charge the battery through this process. So that's what regenerative braking is. Then we go into system design detail. So what system design is and what we'll deal with. So we'll deal with a performance-based design that basically requires you need some requirements in terms of performance, and we'll see if that system architecture meets those performance in terms of acceleration, in terms of fuel economy, etc. So for that, first we need to know what the inputs are. So for this P0 hybrid, we need to know what the engine operating condition is, what the engine drag or the engine braking is, what are the starting dynamics, since you'll be starting and stopping the engine. So how does the engine behave in that dynamics? Because starting and stopping the engine is a pretty rough operation, and that can provide a lot of vibration also. So you need to know those conditions. You need to know when you want to start the engine, when you want to stop the engine, because every time you stop when the vehicle goes zero, you wouldn't want to stop the engine. There needs to be some time delay, after which you might say, okay, this is a long duration, I can stop it, or something like that. So you need to know those conditions before designing them. You need to know what the desired boost and regen capability is. So what the customer would like. Would the customer like a lot of boost or like less boost? So if you're how the regen capability should be, how much you can provide to the battery. It's all the system-based requirement, because even if your motor can provide more boost and more regen, your battery won't be able to provide that much energy. So you would have to design both of them simultaneously. So for designing these aspects, since there's an electric motor, you need to know what the torque speed curve is, like the power curve. So on the right side, you can see how a typical torque speed curve for an electric motor looks. So it starts from 0 speed, you can provide max torque, and then after 1 speed, it goes into max power region, and the torque starts dropping. So this is how a typical electric motor looks, and you have to know this curve or design this curve, come up with a specification for that for designing the system. It has that. It has a maximum speed, to what speed you can run the motor, and you need to know what the efficiency is, obviously, at all these different operating points. And you need to know the inertia of how much torque and how much power will be required to spin it. So that's for electric motor. Then for batteries, you need to know what the operating voltage is, what the capacity is, the battery cells connected in series, parallel, how quickly you can charge and discharge the battery, what the efficiency is at those rates, what the energy and power density is, etc. So all these are like system level specifications that you need to know while designing the system. On the right side, you can see a typical graph for a lithium-ion battery cell of how voltage changes with SOC, which is state of charge. So you need these curves when you are doing such system design and simulation, or you have to define these curves. Then again, there's an inverter to control the motor and other power electronics. So you need to know what the operating voltage is, how much efficiency they have, how much current they can provide and take. And since this is a belted starter generator, it's connected with a belt to the engine. So there's a gear ratio, there's a belt life and tension specifications. So you need to know that when designing it. Then basically once that is done, there's when you're simulating it, you need to have different models. For a driver, a plant is basically the vehicle, and supervisory controller is the controller of deciding how you're going to control it. Based on how you're going to control it, your efficiency gains will change. So you need to know all that, and then you can do a system simulation and try to find whether you are meeting the performance requirements or not. So that's it regarding the case study. So just to end this presentation, basically, if you are interested in this domain, how you can get into this. So first is obviously you need to have the knowledge for that, and knowledge you can get from your colleges. You can get from online courses such as these. You can do some online reading. There's a lot of material online too. So you have to be interested in this field and read more about them. Then if you want to gain practical experiences, yeah, you can do some research in your college. You can work on some student competitions, your essay competitions and stuff. Sorry, where you can get some practical experience of how automotive field works and how specifically hybrid vehicles work. You can also have some personal projects that you can work on. And obviously then if you get into a company, you can gain some experience from them also from a basic level. One of the major things about this domain is it's a multi-domain system. So you need to know how mechanical components work, how electric components work, how the controls work. So there are different domains and there are different opportunities in which you can go into. And since this is a very it's a current research field, so there's still a lot of work going on. It's not a traditional field where almost all the research has been done. So you have to be up to date with what's happening in terms of research, what new technologies are coming out, what different companies are coming up with. So you'll have to be up to date with those news. And then that's a basic requirement. You need to have good analytical skills to particularly do these kind of work. You need to understand those systems, try to understand how the entire system works together, what the problems can come.